Hello, this is team26 of AI-based software engineering lecture. In this video, we would like to present about our project, GA-based test data generation for DOMPurify. DOMPurify is an open-source XSS sanitizer library written in JavaScript, and we would explain about it in more detail in later slides, but let's just start with a brief explanation about XSS. So XSS is an abbreviation of cross-site scripting, and it is a class of vulnerability found in web-based applications. XSS attack enables the attacker to inject malicious client-side scripts, which are in most cases JavaScript code, into web pages viewed by other users. Such vulnerabilities can be exploited by the attacker to hijack victims' session credentials, enabling the attacker to camouflage as a victim on the website. Or, in general, attacker can run arbitrary JavaScript code in the client side, so in the context of the injected web page, to make cross-site request forgery. To prevent such malicious code injections, websites can employ appropriate escaping logic on user input and apply sanitization before saving and displaying the web pages to the user. Our project targets DOMPurify, an open-source, widely used XSS sanitizer library written in JavaScript for HTML, MathML, and SVG. When user input with malicious script is fed to DOMPurify, it strips out everything that contains dangerous HTML code and prevents XSS attacks. So for the example, consider this code was given as the user input, which will be shown in the bulletin board of some website. And this part of the code is a JavaScript code that redirects the user to malicious website with a cookie of current context attached after the URL. Without proper sanitization logic, this article written in the bulletin board will cause XSS attacks to its viewer. So this is a web page for the demonstration of DOMPurify. After sanitizing the user input with DOMPurify, the resulting content of user input would be filtered out as the one in this box. As you can see, the script tag containing the JavaScript code has been filtered out, so the resulting content does not have any malicious code. However, lack of code coverage or performance and potential vulnerability of DOMPurify might be reflected to the web services, causing denial of service or sanitization bypass. So, we aim to generate test cases that can sufficiently exercise the sanitizer measured in terms of code coverage while also being concise. The exercise will base on the seed test data collection from domain knowledge including HTML and SVG, MathML tags, or special characters, or etc. We plan to apply genetic operators to generate various complex test cases. Our final research goal is to construct a test case generator for testing DOMPurify based on genetic algorithms. We also expect our research to be adaptable for other HTML sanitizers such as PHlib XSS sanitizer or Naver Lucy XSS filter. So to explain our plan on approaching the task in detail, we would first understand and learn about HTML tags and sanitization logic of DOMPurify. Secondly, we would develop framework for parsing and manipulating HTML test cases. Thirdly, we would test JavaScript engines which are capable of instrumentation and code coverage collection to extract coverage features from DOMPurify's implementations. And lastly, we would design appropriate genetic operators to generate test cases. To evaluate our design on the test case generator, we will run the test cases on DOMPurify and evaluate the code coverage matrix, feeding the evaluation result back to the test case generator. Finally, we will evaluate the test case generator by comparison to random search and grammar-based fuzzers. And our final aim on the research is to develop test case generator which is superior to both of them. Thank you for watching the video about explanation on our project. Hope you have enjoyed our presentation. Thank you.